Morning, everyone. I welcome everyone for the fourth day, first session, lecture 10, integration of ammonia with renewable energy sources. So we are going to combine the different renewable energy sources which can be utilized for producing the ammonia. So far we have discussed the solar PV and the wind, right? So we are not having much idea about the thermal route. Today I am going to explore some of the thermal mode of power generation, which is also the part of the renewable energy source. So here, solar, the energy can be form of photons entering into PV, photovoltaic cell. Here solar radiation directly converted into electricity. Easy. There are another route is there. What is the thermal route? Similar to our conventional thermal. We not produce electricity from different sources like solar, then biomass, CO, so here today I will talk about how the solar energy is harnessed, converting solar irradiation into, I can say, heat, right? Heat in the form of steam. How the solar energy, which is released by the sun, converted into steam. That steam is used for producing the mechanical energy. Followed by electrical energy. Similarly, biomass. From the biomass, we can use either solid biomass or liquid biomass or gaseous state of biomass. Solid, you can use it as a conventional, like I say, thermal power plant, as a raw material or fuel. Liquid is also can be utilized. Gaseous fuel also can be used. Whereas the liquid and gas fuel, you can not only use it in thermal power plant, we can also use it in gas turbine. Gas turbine. So here, thermal power plant, I can say, is also called steam power. Steam power. The term steam power plant itself gives the meaning. You can produce the steam. You can produce the steam from the heat. That steam is going to convert it into power. In order to convert steam into power or in order to produce the steam, you need a plant which has several components. You have several components. So based on the second law of thermodynamics, you know that you need to heat in two forms. One is heat has to be supplied, heat has to be rejected. Similarly, in terms of work, need to produce the work, also you need to absorb the work. So if anyone is missing, you cannot produce the power in the as per the second law of thermodynamics. Okay. Now I am going to talk about how the solar energy is harnessed for producing the steam. There are two ways solar thermal route. solar thermal route by using organic Rankine cycle. Organic Rankine cycle. Another one, we have CSV, concentrated solar collector, we can say. Here, the organic Rankine cycle, ORC, the organic Rankine cycle, the working fluid is not water. The working fluid is low temperature fluid, we call it as preferably refrigerant. So we are using ammonia, whatever may be the refrigerant, okay? So chlorofluorocarbon, freons, right? Then the hydrocarbon refrigerants. We have to ensure that the working fluid, the boiling point of the working fluid, we are going to use an organic Rankine cycle, even at atmospheric temperature, can able to produce the steam. So in this organic Rankine cycle, you can have a simple solar water heater. Generally, we are using in the house for rising the temperature of water from ambient to some level. So you need something like solar water heater kind of something. So you have a flat plate collector. So you can send the organic fluid. The temperature may be assumed that 50 to 60 degree is available in the heater, which can be sent it to the organic Rankine fluid. Organic fluid, we can say, we are going to produce steam. The steam, this can be utilized or power generation. So we need a work producing device called turbine. Turbine is a device, is an expansion device where you can able to reduce the, I can say, pressure from high pressure to low pressure. So we need to ensure that the organic fluid is entering at some desired pressure. So you are going to produce the work output. So if you connect the turbine shaft with the generator shaft, you are going to convert into electricity. Then, so we are providing heat, okay, as per the second law, we are providing the heat, we are producing the work, the turbine, work is coming out. So we need to include two more components, because once the working fluid we are using in the system, they have to be used again and again. You may come across in the refrigerator also. The refrigerants are stored in the compressor, and it is going to be the same working fluid has to be used again and again continuously for several years. Okay. So same way, this is the organic liquid in the form of vapor is coming. It's in the gaseous state, where the temperature of the steam is more than the corresponding, I can say, it's a supercritical state. Then, in order to, here vapor is converted into, I can say, here it is superheated vapor is entering. That means it is the superheated vapor means the fluid is having the temperature more than the boiling point of the boiling point correspond to the pressure. That will be called a superheater, something like the man or Superman, right? So man has this, everyone having the same figure, but Superman has the extra, I can say, Superman has the extra power. We can see that in the movies also. Similarly, this steam, superheated steam, it has some kind of energy which is more than the boiling point correspond to the pressure. So the temperature will be higher than the saturation temperature. We are going to reduce the pressure. Assume that here pressure is 1, pressure is 2. So we are going to drop down the pressure from P1 to P2. So by doing so, the volume increases, pressure drops down, work is coming out. So as you now know that work is nothing but specific volume times delta P. How much the specific volume of the fluid is entering, how much the drop in pressure. So the delta P, if it is more, we will get a more power from the turbine. That power is converted into electricity by connecting the suitable, I can say, alternator or alternative. Now, the working fluid has to be used again and again. Then you need to use another device called condenser. Condenser is a device used to condense the vapor into liquid. It has to be rejected. So purpose of the condenser is to convert vapor into liquid. Purpose of the, I can say, the heat supply device solar water heater is to produce liquid into vapor. Both are opposite. One is converting liquid into vapor, another is converting vapor into liquid. Because we need to use the working fluid again and again. In order to use the working fluid again and again, you need to pump the working fluid to the solar water heater. So the pump will pump only the liquid. So in order to make the working fluid attain the liquid condition, you are using the. Now, to rise the pressure from low pressure to high pressure, produce the power again, what you are doing is you need to add the work from the surrounding. So you need to add the work. The feed, you have to feed it. That's called, the device is called. But this is the basic thing. Whatever will be the discussion I am going to discuss, respect to biomass based or organic thing or concentrated solar collector. Same. So the concentrated solar collector is something like your heliostat mirrors are there, several mirrors are there. You are going to focus the solar radiation into a, I can say, to the tower. Something like in the earlier days during our childhood time, right? We are focusing the solar radiation to create a fire. So same way, you are collecting the solar radiation and it's focusing at some point. It's called concentrated solar collector, where concentrated point you have the boiler. Okay, the CSP is also similar to this concentrated solar power plant, where you can have all the kilowatts of mirrors are placed on the ground. All radiation falling on to the mirrors are focused at one point is called concentrated. So concentrated at one point is called CSP. So something like it's called the reactor. The reactor is on the tower. On the tower, you have small heliostats across on the ground. So all the radiation falling on the heliostat will be focused into the we can say concentrator. We can say it's a boiler. So inside you are adding water. Due to the high intensity of solar radiation, we are going to get a superheater. This vapor is considered as a working fluid for producing the power by using the work producing device called steam turbine. Then again, it goes to the device called condenser. Convert the vapor into liquid. Then same water can be utilized again and again. It's a closed circuit. Okay. I am going to talk about the different integration of renewable systems. What are the learning objectives? So to explore the integration of different renewable energy sources systems, solar, wind and hydro, geothermal and biomass into ammonia production process. Ultimately, the energy input for producing the nitrogen and for combining the nitrogen with hydrogen, we are using renewable. That is solar, wind, hydro, geothermal and biomass. So to evaluate the technical and economic feasibility of ammonia-based energy storage and transportation system. So at the outcome of this presentation, we are going to know about how the integration of different renewable energy sources is for producing the ammonia. What is the role of renewable energy in the green ammonia transition? Technological approaches to integrate renewable energy source in ammonia production, economic and environmental. So here, the traditional way of ammonia production from the hammer bush, you know that we are emitting CO2. So to eliminate the CO2 completely, we are going for carbon capturing system because blue ammonia. Or in order to completely eliminate CO2 without using a carbon content raw material to produce, I can say, hydrogen, we are using water as a substance to produce the hydrogen without producing the carbon-based emissions. So here, we are producing integration of ammonia with renewable resources, contributes to the global impact, contribute to climate change mitigation effects, open new economic opportunities. So new industries are coming up, new startups are coming up, right? So government of India and many can say across the world, right? People are giving providing lot of fund industries and the government agencies are providing lot of funds to work on this green technology for producing ammonia as well as hydrogen. So government DST already I can say in the website they are going to focus on green hydrogen and green ammonia. Manali already got the fund from the government of around 500 crores to establish the different facility by the industry as well as the academic sector. So renewable pathways to sustainable energy. So we can combine all those things, but wind, geothermal and solar. Water is there. You can take it to the electrolyzer. You can produce the, I can say, hydrogen. Then hydrogen combined with nitrogen, which comes from the, I can say, air separation, processing absorption or the cryogenic waste separation method. We need to bring it to separate out nitrogen from the air. Then you combine it here. So now we already discussed anode, cathode. So the dissociation of water happens at anode. H plus passes through the electrolyte. Electron comes through the external circuit. The anode cathode point, you are going to combine the hydrogen comes from the anode through electrolyte, and the nitrogen is going to be reacted with the H plus. So we will get the ammonia. So the green ammonia, which can be used for, I can say, either for as a fuel, or we can dissociate into hydrogen, then we can use it for some application, or we can use this ammonia for producing the fertilizer. Okay. So, and also we can produce the ammonia through the conventional route with using a carbon capturing system. You can able to produce it. But we are our aiming here nowadays, I can say, we are to eliminate this system completely to go for this kind of system. So solar PV, we already discussed that. Solar photovoltaic cell system is to produce the current, then which can be used for a different application of either for producing the hydrogen or ammonia. Then I discussed that about how the thermal energy is going to be plays a major role in producing the electricity, which can be used for producing the hydrogen as well as ammonia. So ammonia carries the, I can say, hydrogen. So India has a vast wind energy potential. So next renewable energy is wind energy. We have a wind energy potential of 302 gigawatt, and already Tamil Nadu, Gujarat, and Maharashtra is explored, I can say, the wind energy and installed the capacity in 2024, 44 gigawatt. Our target is we have a potential of 300 gigawatt, but almost we can say 44 gigawatt power we are producing now in 2024. So we are going to attain the target in the coming years. The country also holds a significant offshore wind. Offshore winds in the sea itself, they are going to install either in the form of fixed one or the floating type of arrangement. Around, I can say, 7,500 kilometer coastal line, they are going to, I can say, produce the energy, wind energy conversion that will happen. And the government policies and incentives are driving wind energy growth through challenges like land acquisitions are the challenges. So in order to go for onshore, I can say, on the land, we need to acquire a lot of lands. So there will be always conflict of acquiring the lands going to happen. The way we are going for, I can say, new airport or I can say new road pathways, still the problems are existing. So government needs to take care of all those things to have a successful, I can say, exploitation potential of 302 gigawatt. So this is the thing, offshore wind energy potential process. Here we can see here, we are using a seawater and we are going to compress it into the, I can say, by pumping into the desalination unit. So because water, a lot of research is also going on, not only produce the hydrogen, but also to convert this hot water into, you can say, saline water into a drinkable water. So, as the question was posted, why don't you use the seawater for producing the hydrogen? This is the answer. So seawater having some kind of minerals, salt, which can going to corrode the component. So to avoid that, you can you can extract the water through the, I can say, solar desalination plant. So you are going to provide the heat in the form of solar radiation. Then due to the evaporation method, the salinity water is going to be there at the bottom. Then the drinkable water, due to the low density of the fluid, is going to come out. It is going to be used as a, you can say, water for producing the hydrogen through electrolysis. Okay. So this is the offshore wind power generation system. So here we need hydrogen and nitrogen. Hydrogen we are producing from the salt water or sea water. Through the desalination of salt water into drinkable water, I can say, that can be used as a raw material in the electrolysis system by using alkaline electrolyzer or polymer electrolyzer or solid oxide electrolyzer. So from this electrolyzer, we are producing the hydrogen. Then, yeah, we can go for either PSA, processing absorption method, by providing the mechanical energy to the, I can say, to the PSA system to maintain the difference in pressure. You can separate out nitrogen and oxygen, or you can, the same way what we discussed yesterday, to separate the ammonia by using the deep freezer. Same way, oxygen and hydrogen can be separated by using a distillation, cryogenic low temperature chamber, where everyone is having some boiling point. Oxygen having some boiling point, nitrogen also having boiling point. So you can operate it at a particular temperature. You can separate out the nitrogen. Then from the cryogenic distillation unit, nitrogen comes out. Then you are taking out hydrogen from the electrolyzer. You are going to combine the hydrogen comes from the electrolyzer. Nitrogen comes from the cryogenic unit. So nitrogen, hydrogen is compressed into the compressor. For that you need a power. You need a power input from the surrounding. That power you can take it from the mechanical power directly. You take it from the wind energy conversion system. Now the pressure is increased. Then you are going to take it to the, I can say, reactor, something like a Haber-Bosch reactor. So I can say hydrogen and nitrogen goes, and we are going to maintain the pressure of, I can say 300 to, I can say 100 to 300 bar by using a compressor. The rise in pressure happened by using a compressor. To rise the pressure from the input pressure to the required pressure of the reactor, we are observing the work from the surrounding, from the wind energy conversion system. Now, you are rising the pressure by using compressor about, I can say 200 or 300 bar, but we need temperature also to produce the, ammonia. So in order to rise the temperature, you are using a heater. Heater maybe, even you can say some renewable fuel, you can use it to produce the heat, or some kind of, maybe I can say, electrical or microwave or plasma kind of technology can be brought in here to rise the temperature of combination of nitrogen and nitrogen comes out from the compressor, is to heat it to the temperature of 400 to 500 degrees centigrade. Now the pressure and pressure increases due to the compressor, the temperature increases from the heater, then you are maintaining the condition in the reactor. Ultimately, you are going to keep the catalyst, ferrous-based catalyst or lithium-based catalyst to convert the to react the hydrogen and nitrogen as an exothermic process. The presence of catalyst are going to produce the ammonia. The ammonia is living at high temperature, so high temperature and pressure. We need to recover it, that energy. So we need to put some kind of waste heat recovery system. We call it a chiller. So you can supply some coolant to absorb that energy. That is also part of the energy you are going to add it into the system. Then after that, after separating out, after the temperature comes down to the required expected temperature, then you are going to separate out. There are, along with the ammonia, there are nitrogen will comes out, and nitrogen bases also will comes out in the form of NH, NO. So many things will comes out. So we ultimately, by going for chilling, I can say we are not only recovering the waste heat, and also we are going to separate out the ammonia. Ammonia from the different mixtures will be taken out. Yesterday we have discussed that one. So you can operate at some temperature, boiling point of or condensate temperature of ammonia. Ammonia alone condense. Other traces will be again sent back to the compressor. It is going to be closed cycle. So the conversion for your first try maybe I assume that there are 60-70%, but keep until circulating the unreacted nitrogen and hydrogen traces is going to be subjected again to the reactor. Will ensure that all the hydrogen compounds are completely converted to ammonia. Okay, so here the dashed line talks about the energy flow in the form of work. Okay, dotted line. So you have to supply the work. You have to supply the mechanical work or electrical work to operate the compressor. Whereas the continuous line, this arrow talks about, this is nothing but a mass flow. So air is entering some mass. Similarly, that hydrogen is also entering some mass. So some mass of nitrogen, some mass of hydrogen goes to the compressor. The total mass entering the compressor is the mass of nitrogen plus mass of hydrogen. Then we call it as the exit. The total mixture is nothing but mass of nitrogen and hydrogen is going to be taken into the reactor. We need to ensure that the mass of hydrogen and mass of nitrogen supposed to be equal to mass of ammonia. So initially it may not be equal, but several I can say recirculation of the unreacted mixture into the reactor again and again. We need to ensure that mass balance. Mass in is equal to mass out. Mass in is equal to mass out. The mass out, it is not only for I can say ammonia, other constituents also there. If you sum it up, all the mass of ammonia with the other constituent, it should match with the how much is entering, how much is leaving. So advantages: ammonia from offshore wind power, clean renewable ammonia production, CO2 reduction 80% less than the fossil based, no land or water scarcity issues, exploits best seaweed resources. We are expecting, I can say, if you are going to install this one on the sea itself, there's no problem of no land competition or space limitation, but the Environmental Protection Agency will have to clear it, because when you are locating all the windmills in the offshore in the sea, there is a possibility of the birds can say going to hit or something. So the seawater aquaculture will be going to be affected. Okay, so marine can say, but alkaline electrolysis is the mature technology. Electrolysis, you can use all the kind of system we have discussed in already when it compared with Haber-Bosch. But what is the drawback in switching over from Haber-Bosch to renewable basis? High energy consumption and high, I can say, capital expenditures needed, high operating expenditures also needed. Right? High transmission cost, because you need to transfer the electricity from the water, because the plant is located in the sea. So when you are going to if it is located in the land, you can easily transfer to the grid. But if it is located some kilometers away from the land, you need to transport the electricity. So for that, you have to pay extra cost for transporting. But when you are dealing with electricity, because water is conductive in nature, you need to go for highly insulative or non-conductive cables to transfer the energy. The biomass, I think we are going to give demo on that probably in the coming class. How the biomass is going to be utilized in the gasifier to produce the synthetic gas. So from the synthetic gas, you need to separate out the hydrogen, and that hydrogen can be used for, I can say, ammonia synthesis. So you know that the gasifier, there are several types of gasifiers are there. The term itself is meaning is there. The output of the system is going to be gas. Maximum, I can say. I didn't say that only gases comes out. So when you say gasifier, the product is going to be gas. Maximum, maybe 75 to 80%. So it's something like a reactor. Gasifier is something like a simple reactor. It has I can say air entry, and you are going to allow the fuel. I can say fuel is a biomass. Now, what is the difference between combustion and gasification? See, they are using the concept called gasification. What is the fundamental difference between gasification and combustion? So the combustion, we are burning hydrocarbon with oxygen, I can say the 3.76 mole of nitrogen, we are producing the CO2 and water. Along with that, we are going to produce the, I can say, oxides of nitrogen, or maybe I can say the nitrogen is not going to react, so we are going to get nitrogen. The temperature is more, you can have the nonsense. This is the stoichiometric reaction, but normally we are eliminating but this part of the combustion. So here our ultimate aim in the combustion is we are completely oxidize the constituents in the form of either the form of solid or liquid or gas into a product. Products of combustion is complete conversion is happening here. What is gasification is, we are supposed for burning 1 kg hydrocarbon, we are providing 15 kg air, right? So we are going to get carbon dioxide and water vapor along with the nitrogen dioxide. Here, that is called stoichiometric reaction, for example. Now, the gasification is also called partial oxidation. Gasification is called partial oxidation. That means how much, suppose if you want around, I can say, to satisfy your stomach, stoichiometrically, you need maybe I can say 4 dosa, right? 1 juice or 2 egg or something. That is the stoichiometric condition for the adult of age of 30 years. So if you are providing something exactly 4 dosa and 1 juice or 2 egg, we can say we are satisfied. Exactly what is needed, exactly. Suppose if you want to buy something, the cost of the particular product is 100 rupees. If you have 100 rupees, you can buy it. If you are having more than that, also you can get the balance. If you are giving less, if you have less, you cannot buy the product. So that is not possible in the combustion. In the combustion, you can supply the exact quantity or you can supply a little more than that. So we ensure that products of combustion is complete. Here, it is a partial operation. Suppose your son or daughter wants 100 rupees to buy this, if you are giving only 30 rupees. So they will partly, I can say, there are n number of items are there. 10 items can buy 100 rupees, but you can buy only if you give 30 rupees. What is possible for 30 rupees? They will calculate. Here, I am going to burn 1 kg of hydrocarbon into 20 to 30%. 20 to 30% of the stoichiometric requirement. I am going to do the partial oxidation. I may get carbon monoxide. I may get carbon hydrogen. So I may get the hydrogen, and along with that, I am going to get carbon dioxide. Then you are going to use, so nitrogen also will come along with that, oxides of nitrogen will come. So if you have only hydrocarbon, we have, I can say, the following products. This is the complete product, no problem. So this is the product of the summation of, I can say, the combination of CO and H2. We call it as producer gas. We are producing the gas. That's why it's called. And also it's called synthetic gas, syngas. The gas comes out from the gasification. It's called synthetic gas. So from the gasification system, there are 4 different chambers are there: drying, pyrolysis, right? Oxidation, reduction. So reduction, oxidation, pyrolysis, then drying. The zone may change for different things. Ultimately, the gas comes out. If you are going to take it from the downside, it's called downdraft gasification. Gas, the bottom, you can say downdraft. If you are going to take the gas at the top, it's called updraft gasification. So if you are going to take the gas exactly center, maybe you can say grass draft gasification. But ultimately, the gasification system used to produce gas maximum, but I did say that I am not going to get only 100% gas, but I will get some percentage of liquid also, some percentage of solids. Correct? So, how to have the liquid, the pyrolysis process happening, you may get sometimes The bottom you will get a liquid kind of thing also, solid also. Each one has some application. Suppose you are going to burn, I can say, we take it to the biomass, corn stock, or I can say wooden stock. So you will get gas, maybe I can say at the bottom, due to the condensation, you will get a liquid along with the solid. So solid is nothing but the activated carbon. It is also used as a fuel for running the boiler. You can supply it to the steel plant. You can supply it to the even activated carbon has several applications. Wastewater treatment, many things are you can use it. Activated carbon is a catalyst for same process itself. So what we did is the gasification, whatever maybe the solid particles are coming out, activated carbon, we converted that one into metal impregnated one, the carbon. We can able to convert it to the catalyst, which can be used in the gasifier system itself to reduce the activation energy of the process. Yesterday, Professor spoke about by using a microwave, we can able to reduce the energy. Right? Only the container in the atmospheric temperature. Inside the food is going to be having the expected temperature. That condition you can able to attain it. The gasifier, I think we have the small prototype 1 kilowatt gasifier is there. That one of my scholar Lakshman is working on it. He's tried several, can say, biomass. One of my scholar, he completed the PhD by using a gasification system, where he has ultimately the gasification we are going to produce CO and hydrogen. What are the methods in which you can able to increase this kind of the gasifier? So we can have a pre-treatment. We can have a pre-treatment method, and also we can have post-treatment. I'm not going to explore more on that. So that is things are available. When you feed the biomass material into the gasifier before itself, you can do some kind of acid latching or something. The biomass material you can able to enrich the nitrogen content by using you measure the ultimate analysis. You go for any biomass, go for approximate and ultimate analysis. Maybe you can say this plays a major role. Any biomass you want to try in the gasifier, you can do approximate and ultimate analysis. Ultimate analysis talks about CHON, presence of carbon, hydrogen, oxygen, nitrogen, sulfur. Then for biomass, sulfur is going to be approximately 0%. That's the reason why the biodiesel production and all, we are using the non-edible oil to produce the, I can say, biodiesel, which can be have the equivalent quality of the diesel, which can be used in the diesel engine directly without any modification. Approximate analysis, we are finding out the fixed carbon, moisture, ash, then volcanic. We are finding out. So any raw material, initial study, whether you want to use that raw material for producing the synthetic gas, we need to do the first approximate and ultimate analysis. Ensure that it has the potential. Suppose you are having around 100 biomass sources are available. Among these, you want to try the best out of the 100 or maybe top 3 among this, the first study you need to do. Then you need to do the, I can say, energy content. Energy content of the biomass by using a bomb calorimeter. So bomb calorimeter is a device used for measuring the calorific value in terms of kilojoules per kg or megajoules per kg. So it's a constant volume bomb is there. This facility is also available in our laboratory. If anybody wants to explore it, you can contact us. We can support. Okay, this the bomb calorimeter is for measuring the calorific value of both solid and liquid. Whereas for finding out the calorific value of the synthetic gas, thin gas, we can take it to the either maybe I can say GC. We have the onboard GCs available. You can use it. Find out different hydrocarbon. You can use it. Then find out the calorie energy content, or you can go for the Concur's gas calorimeter. It's an online system calorimeter. You can measure how much the energy is going to be liberated when you burn unit volume of the fluid. That is very important. We talk about the gas. The unit is megajoule per meter. If you want in terms of, I can say, megajoule per kg, you need to multiply by density of the gas, which is coming out corresponding to the temperature leaving from the gas. So here, unless otherwise, if you are not understand this one, it is very difficult to, I can say, by using our gasifier, how this one is going to be used. So gasifier, we are producing we are supplying 20 to 30% of air. So 20 to 30% of oxygen. 15% means I can say 1 kg means in terms of mass basis 0.23. Oxygen is there. Remaining 77% is nitrogen. So we are interested only in oxygen, not nitrogen. Okay. So if you put 20 to 30% air, corresponding to 20 to 30% air stoichiometry, we will get a relevant oxygen, and it's going to be reacted. The what's the oxidation going to happen in the gasifier? Then the gasifier, there are several applications. The gases comes out also coming with high pressure, not high pressure, high temperature and low temperature. So if you are going for abrupt gasification, you are going to take the gas at the top, then the temperature of the gas is around 400 to 500 degrees centigrade. So you should not use it. Suppose you want to use the gas for engine applications, right? Then you cannot use the gas comes out from the top of the gas because at high temperature it has a top. So when you allow the gas into the engine, the intake manifold, it is going to be deposited on the components of the engine. So you need to cool that before you take it to the atmospheric, remove the top from the gas, then you can use it. So you want to produce if you want to use the engine, you can go for downdraft for producing the power. If you want to use, I can say, steam thermal power plant to produce the power, you can go for updraft because 500 degree, 600 degree temperature of gas is leaving. We can save that which is used for producing the steam in the boiler. The W is nothing but waste gate recovery reactor. Okay, waste gate gas reactor. So the gas is going to be send it to the steam production device where you can able to recover it. So if you can use a fuel for producing the energy, or you can recover the heat recovery steam generator. This is nothing but heat recovery steam generator. You can take it to the turbine for power generation after bringing the number from 600 to normal 30 to 35 degrees centigrade. The amount of heat available in the synthetic gas is going to be absorbed, which can be used for heating the water. Now, as the biomass contains carbon, so we need to take care of the carbon capture system. CO and hydrogen is coming out. So the CO, the percentage of carbon is going to be lesser than the percentage of carbon comes out in the form of combustion. That carbon may be converted to carbon monoxide. You can convert it because the carbon monoxide is a non-condensable gas. You cannot condense it. So you can use the same carbon monoxide again into the gasifier. You can send back to the gasifier, produce the heat because carbon monoxide is a fuel. Actually, it's a good combustible fuel. It's not. It's an incumbent bond product. It's not CO2. So you can use it in the gasifier itself. Recirculate it. You can use it for producing the heat for producing the synthetic gas. So you reloop it. Okay. Then from that, from the CO2 will be entering into the gasifier. Then the nitrogen which comes out is going to be taken into the ammonia synthesis. So you are going to take the hydrogen from the gasifier, then it goes to the ammonia synthesis. So here hydrogen comes from the gasification system, enter into the reactor. Then nitrogen comes from the ASU, so air handling system, where you can say oxygen you are supplying, whatever may be the PSA or cryogenic kind of system, you are going to bring it to separate nitrogen and oxygen. Nitrogen taken for ammonia synthesis, oxygen taken for gasification. Normally, this is a good system actually because if you supply air into the gasifier, the formation of oxides of nitrogen is also there. If you separate out the nitrogen oxygen, the air handling system itself, if you supply only oxygen, there is no possibility of oxides of nitrogen comes out from the gasifier. So even now we are suggesting that in the engine, instead of supplying air into the diesel engine combustion or petrol engine combustion, if you put some kind of air handling system at the before the filter or after the filter, you can separate out oxygen nitrogen. If you send only the oxygen into the combustion of petrol or diesel in the engine, there is no possibility of oxidation of nitrogen comes out. But how to separate out oxygen nitrogen very quickly to take care of the demand of the engine, that is a big research is necessary. So here you can see here there are several biomass sources are available. So starts with wooden waste, animal waste, rice straw. Then someone comes from, I can say, Andhra or from the Tanjore or rural region. There is so much of rice straw going to be there. That is, if you want to install some kind of, I can say, gasification system or renewable system to produce ammonia or hydrogen, so you can make use of the source available in the nearby place itself. Even the bagasse, sugar cane waste we call it as bagasse, animal waste, then municipal solid waste. So people are now I can say so a lot of research is going on. A lot of people, industries are getting revenue out of it now. How to convert the waste into useful energy or convert it into waste into wealth. So people are working on this one also. These are the different biomass of food waste also, food waste, industrial waste that you can take it as a raw material for producing the bioenergy through the combustion mode or gasification mode or pyrolysis. So here, the combustion, we will get only the products of combustion in the form of gas, bond product, whereas the gasification, you are going to get solid, liquid, and gas. Here the gas is predominant. Gas is predominant, whereas the pyrolysis, you are also getting three products, solid, liquid, and gas, but here the liquid is predominant. So you are converting the solid material into gas completely. Maybe I can say 10 to 15% is solid residue. Remaining 85% going to be converted into gas. In that 85% gas, something is going to be condensed, something not going to be condensed. The condensed gas is nothing but liquid. So the product of the pyrolysis reactor is the maximum going to be liquid. So we can produce the biogas from the anaerobic digestion, which is rich in, I can say, methane. So that methane we can use it for, I can say, the hammer bush root or the other kind of roots to produce the hydrogen out of it. But when you are using hydrocarbon fuel, the carbon capturing unit is mandatory. Geothermal. So this technology is not emerged in India like other European countries, but it needs some kind of potential to tap the energy, right? So geothermal means you know that the pressures are pressure and temperature. Pressure going to be when you go from the ground level to the I can say to the elevation of some height, then the pressures are start decreasing. Whereas the inverse in case of the under the earth. So when you go down, the pressure maybe I can say from the earth level to the 10 kilometer from the earth down. So we get high pressure and high temperature. So what is the purpose of geothermal is? Geo means so we are going to generate energy from the underneath of the earth. So there are a lot of potential of heat is available. Even you can say whenever you want water, or I can say you want to construct a house, you have a plot, right? So you want to construct the water. First thing you are doing is you are going to bore it, right? You need a water for. You are going to put a bore. So high pressurized water is coming out. You put a, I can say maybe 300 feet or 500 feet or 1000 feet. You get a high pressure water is coming out. Same way, you put a drill under the earth, find out the molten or the heat available at the molten lava at a particular point. You inject the water on that. You inject the water on that point. So we get, I can say, when you inject the water into the high temperature, high pressure zone underneath of the earth, you will get high pressure, high temperature. Superheated steam will be coming out. That steam is going to be utilized for power generation, something like a conventional steam power plant. Or that the potential of heat is less, you can go for organic Rankine cycle where you can replace the water by using a low temperature fluid that can be used for producing the power. So there are other things are remain same. Biomedical for producing hydrogen, then air separation used for producing the hydrogen. You are going to combine both the things. For that, you are going to supply the energy wherever is necessary across the components from the either mechanical energy or electrical energy. From the plant, the power plant, what we are designing from the organic Rankine cycle, or the pressure temperatures are low, the water is sufficient to convert into vapor. That also we can think about producing them. So geothermal potentials, we can say, they are identified across the world. The geothermal potentials are available in Philippines and US, particularly California. And then in India, they have identified a place called in Andaman and Nicobar and Himalayan region. And particularly the states of Himachal Pradesh and Uttarakhand, they have identified the potential, and Andaman also they have identified some kind of some geothermal potential available, particularly in Indian Ocean zone. distribution of, I can say, different renewable energy sources compared with the, I can say, conventional also. We can see that still the natural gas, I can say, and the coal is dominates for the power generation. Coal is almost 35.43. Natural gas is about 23.57. So almost I can say 60% of the total power comes out throughout the world through the conventional sphere, particularly coal and oil. Remaining 40% we are exploring through the, I can say, the renewable system. So among these, the renewable source, the 16.16, that is solar, I can say, plays predominantly, I can say, play a major role in producing the energy, followed by nuclear. Nuclear is also, I can say, it's a conventional one. So by adding all those things, maybe 10 plus 36, 46 plus about 49 and 69, up to almost 70% of the power comes out. Still we are extracting from the conventional source, 30% only we are extracting from the renewable. So still a lot of, can say, exploration necessary to move at least 50-50 in the near future. So the role of geothermal energy, reducing emissions, and geothermal energy is a continuous power is possible because not like solar or wind. Continuous power is possible because we are going to drag the steam from the underneath. So a lot of earth crust we have the molten lava. It is few thousand kilometers of it is available. So for several years you can produce a continuous steam for power generation. Okay. So this is a mature and cost-effective renewable source. Because when it's not mature and cost-effective cases, we are not going to spend even, I can say, single paisa for getting the steam. Only thing you need to pour it and supply the water into the point where the high temperature and high pressure heat is available. So hydroelectric, we already know that. So we have the in Tamil Nadu, we have the Nadu, and we are producing the electricity from this. We are storing the water in the dam due to the difference in elevation. So we are going to allow the water from the heights of several, maybe few meters height into the downstairs where we are going to keep the turbine. So the potential is converted to kinetic energy, becomes mechanical energy. Then you connect to the generator. We are going to produce the electricity, which can be used for producing the hydrogen, and which can be also used for producing the oxygen, and combination of nitrogen and oxygen also is used for producing ammonia. So we have the different case studies. So in the Asian country, particularly, I can say Australia, they are exploring the different renewable possibilities, solar and wind. And in India, I can say, in the Indian perspective, Indian farmers, they are the Indian, I can say, farmers fertilizer cooperative limited, IFCO. They already started working on it and how the wastes are going to be converted into useful product, which can be used for giving some kind of energy to operate the agricultural pump or for fertilizer for the farmers. So they are the plant is Bulpur and Anola. There are a lot of potential you can see, like livestock or animal waste, which can be taken to the digester, which can be used for producing the biogas. Biogas can be stored at high pressure, which can be used for fuel for running the automotive system, and as well as for the producing the power and the gas turbine as well as the steam power plant. Similarly, here the crops and other things you can use it in the aerobic digester. Ultimately, the digester is a device used to produce the gas from the solid or liquid waste. You are going to produce methane rich in nature. That is going to be used for, I can say, a different sector. But the unused, the residue is going to be accumulated at the bottom of the anaerobic digester. It will be taken, I can say, take out continuously. That will be digested. It is going to be used as a fertilizer for improving the soil quality. So biomass gasification. There are India. We are I can say working on. We are having very good technology for producing the syngas. So IIC Bangalore is leading in it. Then IIT Delhi in the energy department. Then IIT Madras also in the chemical department. Few processes are working on it. So it is a proven technology. It's a lot older technology, and depends on the need. You need to go for a biogas digester or a gasifier. What is the application? You want solid, liquid, or gas, or you want some kind of fuel which is going to be liquid with solid? Then accordingly, the right technology can be used for producing the hydrocarbon products. So these are the questions. How can collaboration between the agriculture, energy, and industrial sectors accelerate the adaptation of ammonia production technologies? From the presentation, these are the possible questions you need to answer for it. What are the potential challenges in integrating renewable resources for ammonia production in developing countries, and how can they be overcome? What would be the global impact on CO2 emissions if all ammonia production facilities are transferred to renewable energy source by 2030? How can the integration of renewable energy and ammonia production impact global fertilizer prices and agricultural practice? How can the use of green ammonia in other industries, whether it's transportation or power generation, further accelerate the adaptation of renewable ammonia technologies? So you can able to do the assignment also. Exploring the role of renewable energy in green ammonia production. Individually prepare a comprehensive writing about a topic. Maybe a type of document is Microsoft Word or PDF. Maybe you can write 1,600 to 2,000 words. So write your own words. So plagiarism less than 5%. Then grading of the particular assignment is based on how depth, how clarity you have understood and how you wrote in that particular document. Comparison of critical thinking skills, structure, grammar, and citations. The deadline for this one is 25/11/2024 for 10 a.m. So these are the references I have used for preparing the PPT. I thank once again Uday Kumar and the other students to help me to prepare the PPT. If you have any questions, you are most welcome. Thank you. If you are not having, I can say, any questions, then we will break forward.